Oh, good morning, guys. Welcome back to our video tutorial. Unfortunately, I was having some problems with my device, so I hope I get to you guys quickly. So yeah, yesterday what we were doing was that we were doing some class C, which has lesser um, host bits, so that we can have a quick understanding. So today I'm going to give you guys also 2-3 samples on class B as well, so that tomorrow I can do class A, classful subnetting, and that will be the end of the week. Then next week, inshallah, we will move to variable length subnet. So next week we should finish semester 1 by all means, inshallah, and then hopefully I'll see what we will do with that and see what we can do. Okay, guys, so we are going to do some subnetting of class B private IP address using FLSM like what we were doing yesterday, and we are going to do some practicals in the next page, and then I'll come back to this page so I can set some questions for you guys to answer. So we start right from here. So that is our private class B IP address. So what we want right now is that we want to subnet this class B IP network into two subnetworks. Okay, so our question is we need two subnets from this network, two subnets, and each subnet, okay, should provide 60,000 users. Okay, that's our question. So that is the question. We need to subnet this network into two subnets, and each subnet should provide room at least for at least 60,000 users. So in this case, how many bits do we need to borrow is the question. So what we will do right now is we have to go with our table that we were using before. So 128. Sorry, I'm using dot. 64, 32, 16, 8, 4, 2, 1, 1. I'm gonna have to do that again because it's class B. So we have to get 64 to 32, 16, 8, sorry, not 9, 8, 4, 2, and 1. So basically this is exactly what we are going to do. So I am gonna add some few things here. I think this thing is a little bit small. Alright, guys, so I am gonna have to do this so we can be able to see everything. Alright, so right when I'm here, I am gonna press the enter key so I can include I'm using computer, so that's why it is a little bit difficult. I do not have all the necessary tools available, so I am just managing what I have at my disposal. So now the formulas are right here. I just put them prior so that we don't have to wait, when we are doing these things. So it is that we want to know how many bits that we need to borrow. So whenever you are borrowing, guys, you borrow from the leftmost side of your bits. When you're facing your screen, the left is right from here, okay, and when you are facing your board, also the left is right here. So that is it. That's why I said from your left. Alright, guys, so that's important. Now, how many bits do we need to borrow? This is similar to what we have yesterday. We just need to borrow 1 bit to get 2 subnets. So if we borrow this 1 bit, the formula is 2 to the power of borrowed bits. How many bits did we borrow? We borrowed 1. Borrowing 1 bit gives you how many subnets? 2 subnets. Okay. Now, how many hosts per subnet? We said we need at least 60,000 hosts per subnet. Now, to get that, we will say 2 to the power of remaining bits. And how many bits are remaining here? The total is 16, because you have 16 bits in the host portion. So if you subtract 1 from 16, you are left with 15. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right here. So here, 2 to the power of remaining bits, we have 15 bits remaining. So we're gonna do this. Okay, we're gonna have to remove this and put 15. And 2 to the power of 15 gives you how much? Oh, sorry. I am sorry, guys. I want 2 subnets, but 60 60 cannot be here, so I have to put here 30. I'm sorry about that. I'm gonna have to put here 30,000 users. 60,000 users means I cannot reduce. I cannot borrow anything. So, guys, I apologize for that. 30,000 instead of 60,000. So if we borrow 1 bit, it will give us 2 subnets. But if we say 60,000, it's not possible with 2 subnets. That means you have to use the entire here. We are not going to borrow anything. So that is the problem. Right now we want to borrow. So we said every department is having 30,000 users for each of these 2 subnets. So it's good that we do some clarification right here before we move. So 2 to the power of 15 gives you 32,768. Okay, 32,768. Let me put dash here. 32,768. We have to subtract 2 from here, and we have equals to 32,766. So when you do subtraction with 1 not, it gives you the answer straight right there. So here, what we were doing the last time with class B, the reason why I told people not to be using the block size, because it does not work for more than class C. If you go to class B, this block size cannot be used. So that's why I always tell people that use the sum of the remaining bits. Now, the sum of the remaining bits here is that you have to pay attention how I do this. Now, this is the 3rd octet, and this is the 4th octet. Okay. Now, in the 3rd octet, we do not have all the bits part of the network or part of the host. So this 3rd octet 0 bit here is now divided into 2. A bit of it is part of the network, and some of the bits are part of the host person. So therefore it is divided into 2. Now when we borrow, we borrowed 1 bit, and we are left with 7 bits in this octet. That is the 3rd octet. And all the bits in the 4th octet are part of remaining bits. So one have to pay attention to that. Now here we have not all of them part of the host person, but 7 of them are part of the host person, and 1 bit is being borrowed part of the network person. So the sum of the bits that are remaining here in this 3rd octet is what we have to pay attention to. Okay, now we have to put the sum of these bits together is 127. So we have to look at that. So the sum of the bits here is 127, and the sum of the bits here